This is the last lesson for Chapter 4. It actually comes from, in the book, Chapter 5, Lesson 7, but I'm putting it here because it kind of fits nicely with what we've been talking about. So this is the last thing in what we're talking about now, but just know it's a little bit out of order from the book. So we've been talking about different ways to graph a linear equation. So with different forms, you have the slope-intercept form, y equals mx plus b, you have point-slope form, and standard form. Now we're going to talk about graphing these things, and we're going to talk about graphing not just equality equations, but inequality equations. So not just lines like this, but inequalities, and we'll get to that in a second. But before we do that, we're going to talk about what a solution is. Now, before, when we're just doing linear equations, then a solution was any point that's on the line. So if I want to talk about a solution to this blue line right here, then it would be anything that's on the line. So right now, it's not a solution because it's not on the line. If it's over here or over anywhere, it's not on the line, then it's not a solution. But any point that's on this line means that it's a solution. So it's a pretty narrow set, even though there's infinitely many of them because it goes off in either direction. It's a pretty narrow set because if I jump off a little bit, then it's no longer a solution. So one way we can check that is to plug it in, and if the equation works, then that point is a solution. Well, here we have an inequality, which is a little bit different, and so we need to check if the point that we're plugging in here, 4, 3, makes 3x minus y is greater than 7 a true statement. So if I start plugging this in here, so instead of x, I'll get 4, minus, instead of y, I'll put 3, is greater than 7. I'll get 3 times 4 is 12, minus 3 is greater than 7. So 12 minus 3 would be 9. 9 is greater than 7, and that's a true statement. 9 is greater than 7. So because that makes this a true statement, then yes, that point, 4, 3, is a solution. That means it's within the solution set, it's within a certain area that this graph represents. And we'll get into what that looks like. Okay? Another example I already have completed is this one over here that you can look at. We're checking to make sure that this thing is less than or equal to 8, and we found out that we got 14. Which is not less than or equal to 8, it's greater than 8. So because it was greater than 8, and it said it was supposed to be less than or equal to 8, that meant it's not a solution, it's not within the area that's considered the solution. So let's go down here when we're talking about graphing linear inequalities. So we have certain criteria that makes it a little bit different than graphing just a normal line. So first off, you can have a solid or a dashed line, and that's going to depend on what kind of things you have here. If you have less than or greater than without the or equal to, let me get rid of those so we don't think it's that, it's going to be a dashed line. But if it does have those extra lines, that means greater than or equal to or less than or equal to, then it will be a solid line. And then if we have less than or equal to, that means we're going to shade this thing. We're going to shade the graph, and we're going to shade it below. But if it's greater than or equal to, we're going to shade that thing above there. So we have this thing to kind of reference, but let's see this in action. So over here, we have graph the inequality. 3x minus y is less than or equal to 7. So there's several different ways that I can take a look at this. Now, notice how I said that we're going to shade it depending on what that is. Well, we're going to have to be a little bit careful here, and I'll show you how. So first off, what I'm going to do is just get the 2 points so I can graph the line. So because this is in standard form, that's really good for the x-intercept and y-intercept of graphing this thing. So one way that I can graph this is just to get the x-intercept. And so how do I do that? Well, if it's the x-intercept, it's somewhere on this line because it's the where it touches the x-axis. So that means the y, or I'm sorry, this is the x-axis. I was getting ahead of myself. So that means the y is going to be 0 at any point on there. So if the y is 0, that means it's not there at all, and so I don't even have to worry about it. So maybe with your finger or a pencil or something, you can just cover that up physically and pretend it's not there, because it wouldn't be there if it's 0. So I have 3x is less than or equal to 1. So if I were going to solve that for x, I would divide that by 3, divide that by 3, and so I'd get x is equal to 1/3. And I know it's kind of a weird point because it's a fraction, but I'm going to kind of guess it in there. It's not even halfway between 0 and 1, so I'm going to put it about here on my graph, and so that's where the x-intercept is. So for the y, it's going to be a little different. So I'm going to do the same thing. I'm going to cover up my x, because it's going to be somewhere on this line, and so that means the x all along that line is going to be 0. So if I have negative y is equal to or less than or equal to 1, well then positive y would be equal to negative 1. So here's my negative 1. And so now I'm going to graph this thing. Now before I actually make my line, okay, don't do it unless you make a determination. I'm going to get rid of this because before I graph it, I'm going to need to know, is this thing going to be a solid line or a dashed line? Well, according to my paper up here that says if it's greater than or less than or equal to, then I'm going to use a solid line. Well, this thing is less than or equal to, so that means I am going to use the solid line. So now it is safe to go ahead and make that line that looks about like that. Now, the next thing I need to know is if this thing is going to be shaded above or below this line. So if I'm going to shade it somewhere above this line, I'm going to shade it above here, or I'm going to shade it somewhere below here. So to make that determination, I need to take a look at my y. Now my y is negative here. So if I'm going to solve that thing for y, then I'm going to do what I actually left out before. I would need to divide that thing by 1. Actually not 1, but negative 1 because of that negative sign right there. So what that'll do, that'll make it negative 3x plus y. I need that thing to be plus, and then there would be a negative 1 over here. But because I divided by a negative number, that'll switch that sign so it's greater than or equal to negative 1. So the y is the important thing here. I go by, as long as that's positive, then I look at the sign. Now, if I read this to myself, negative x plus y is greater than or equal to negative 1, then I look at that and I read greater than or equal to. So if something's greater than, does that mean it's above or below? Well, usually that means it's above, so that's how I'm going to shade it. I'm going to shade everything above this line, so everything above here like that. So it's not just going to be those things, it's going to be everything. So with your pencil, you can lightly shade everything above here. And if you're a little bit sloppy, that's okay, because it actually includes everything beyond as well. But I only have so much graph, so I'm going to get rid of this part. So when I'm looking at a solution, I can have some random point, just like before. And right now, it's not a solution. If it's on the line, it's a solution. And now, here's what's different. If it's anywhere in this green shaded region, then it's also a solution. It could even be out here, because I know it would be shaded. So as long as it's anywhere on this green shaded part, including on the line itself, then it's a solution. If it's anywhere on this side, then it's not a solution. So let's go over to this next one. This one's a little bit easier to graph, because when I do my x-intercept and y-intercept, well, in order to solve for both of these, I would just cover up the y, solve for x, I'd get x equals negative 2. I get y equals negative 2 as well, using the same method. So I'd put my 2 points on here. Before I graph the line, I needed to make a determination. Is this thing dotted or solid? It's going to be dashed or dotted because it's not or equal to. So I'm going to make a dashed line. Looks something like this. Okay? Now, I'm reading this to myself, and my y is positive, so I can use this. Is this thing going to be shaded above or below? X plus y is greater than or equal to, I'm sorry, just greater than -2. So because it's greater than, I'm going to shade it above again. So shaded everything above here. Something like that. Okay, so now we have two special cases on the back. We have graph the inequality y is greater than 2. So this one is a special one where if it's a y, you turn a y upside down, it becomes an h for horizontal. That's how you can remember it. So I'm going to go on the y-axis up at 2, and it's going to be a horizontal line on either side. And I was a little bit low on that one, so something like that. And because I'm reading this to myself, y is greater than 2, it's going to be shaded above, like that. This one's the only one that's going to be a little bit different. I have x is less than or equal to 1. So I have x, and if I cover up the bottom part of an x, I get a v for vertical. So that's another way you can tell. So I have x is less than or equal to 1. So on the x-axis, put a point at 1, and it's going to be a solid line, straight up, straight down. Now, this one's the only one that's different because I can't shade above or below. I can only shade left or right. So in this case, whenever you have an x inequality, then just shade in the same direction that the arrow is pointing. So it's pointing to the left, so I'm going to shade to the left. So something straight down, and you're just shading all those things in there lightly with a pencil. All right, so for this next section, we're going to be doing the exact opposite. We have a graph, and now we want to write the inequality from that. So I'm going to get the equation part first. So I'm going to figure out what my slope is. So from here, which is 4, down 4, so -4 over 4 that way, my slope is going to be -1. So it's going to be a -1x. And then my b is going to be the y-intercept. So if you remember that, it's right over there up at 4, so it's going to be x, -1x plus 4. Now, usually I'd have y equals -1x plus 4, but this time I don't have just an equal sign, I have an inequality. So I need to figure out, is this greater than or equal to, less than or equal to? Well, because it's a solid line, I know it's going to be or equal to. So I'm going to have that extra line underneath. And because this is shaded above here, it's going to be greater than. So I need to make sure that it's opening toward the y. So it's red, y is greater than or equal to -1x plus 4. Here's another example already worked out. So if you need to, you can pause it and take a look at that. All right, the last thing we have here is a real-world example, or at least a real-world situation, where it says you're going clothes shopping and can spend at most $130 on clothes, and it costs $30 for a pair of pants and $22 for a shirt. Let X represent the number of pants you can buy, and let Y represent the number of shirts you can buy. So write and graph an inequality that describes the different number of shirts that you can buy. So here's the way you do this. Well, if we have X represent, what did it say? Let X represent the number of pants you can buy. Well, for a pair of pants, it costs $30. So for every X I get, it's $30, so it's going to be 30X. So if I buy one pair of pants, it's $30. 2 pairs of pants, it's going to be 30 times 2 would be $60. So for my shirts, I'm leaving some space in front of my Y. It says let Y represent the number of shirts I can buy, and it says it's $22 for a shirt, so it's going to be 22Y. Now, I know that all the X's, all these shirts I buy, plus all the Y's, all the pants, or no, X's is pants, all the X's I can buy plus all the shirts I can buy has to be, and it says at most $130. That means I can spend exactly $130. I can spend less than that. So I can spend $129, I can spend $2 if I want to. I can spend no money if I want to. But I can't spend more than that because that's all I have. So to write that, it'll be less than or equal to 130. Okay? So the graphing part, I'm going to do it the same way I did on the front, where I have my x-intercept and my y-intercept. And I'm going to kind of do the same thing I did before, where I'm going to cover up the y and solve for x. So if I take 30x equals, for now, 130, what will my x be? Well, I would take 130 divided by 30, and I get 4.3 repeating. Okay, now for this demonstration, it's good enough just to say about 4.3. I'm just graphing it, and it's just going to be an estimate for this thing. So let's take a look at the y. So I'm going to cover up the x and solve for y. So 130 divided by 22, 5.909 repeating. So for this, it's going to be just fine to say about 5.9. So I'm going to graph those two things on there. So x is 4.3, so a little bit more than 4 on the x-axis. Y is 5.9, so just shy of 6 on here. Okay, and because of this thing right here, where it's less than or equal to, then that tells me that it's going to be a solid line. And because it's less than or equal to, then I know it's also going to be shaded below here. So anything down here. Okay? And then it says, give 3 possible combinations of pants and shirts that you can buy. Well, anything within this shaded region will work. So that means anything down here, down here, down here, on the line is fine too. As long as this gets above here, it won't work. So just pick 3 points. So there's one right there. So that'll be, let's see, that's 1 pair of pants, 3 shirts. So 1 pant, 3 shirts. Okay. Certainly, I can go down here and I can get 0 of each, because that'll stay within my budget, be kind of cheap. And then you can pick some other point here. I wouldn't pick 2.5 because you can't pick 2.5 pants, but as long as you're picking whole numbers, then you're fine. And if you're not sure, this point right here, is that on the line or not? Well, you can figure out algebraically, or you can trust your graph. So it's just a matter of how well you made your graph. And that's an overview of how you do inequalities.